Okay, the best way to solve this logarithmic equation is by starting, make sure you know the properties. And the property here is when you subtract logs, you can divide them. In other words, here's the property. If you have a log of x over y, this is equal to log of x minus log of y. Okay? Because of this property, we can change this subtraction back to division. And therefore, this problem can be written as the log. Of course, we have a base 4 here, base 4. And now we can put this as a ratio. X plus 10 over x minus 5. Okay? And that's equal to 2. So remember, when you have subtraction, you can change it to division. If it's addition, you change it to multiplication. And I have posted those properties of log, so make sure you go over them. Now, the other property I'm going to use to go from an exponential to log or log to exponential. Say you have log of x base a equals y, right? You can change this to exponential by a to the y equals x. See what I did? I used that a here. The base a stays the base. You know, a stays the base here. That a here stays as the base. And then x is equal on the other side, and we go a to the y equals x. So let's do the same thing here. Go 4 to the 2 equals all the fractions. So we have x plus 10 over x minus 5 equals 4 to the power 2, which is 16. 4 times 4 is 16. Over 1, so we can cross multiply. Now to solve this equation, all we have to do cross multiply. So we go like this and like that. And now we end up with 1 times x plus 10, which is just x plus 10, equals 16 times x minus 5. So 16 times x minus 5. Notice this is a very simple linear equation. So let's write one more step. X plus 10. Distribute the 16. You get 16x minus 5 times 60 is 80. Okay? So 5 times 6, 30. 5 times 1, 5. And 3, 80. So now my next step is I want to move the x to the right and move the 80 to the left. So I'm going to add 80 to opposite side. This way, this will cancel. I'm going to add x to both sides. This way, this will cancel. And I end up with 90 equals 16x minus x is 15x. Well, the last step here is to divide both sides by 15. Here we go. Divide this by 15, divide this by 15, and you end up by x 90 divided by 15, and this would be 6. 6 times 5, 30, 6 times 1, 6, and therefore 6 is the final answer. Now notice here we cannot have x equals 5 as the final answer, because if x equals 5, this would be undefined. Okay, or x equals negative 10. We cannot have zeros. We cannot have those to be zeros. Those have to be always positive. And notice if you substitute back the x, 6 plus 10 is positive, and 6 minus 5 is positive. Okay, so x equals 6 is the final answer. All right, let's try the second question. Here's the second question. 16 to the power x plus 7 equals 256 to the power x minus 4. You notice here that 16 is nothing but 2 times 2 times 2. 2 times 2, 4 times 2, 8 times 2. This is 16, right? And also 256 is nothing but 16 times 16. Right? If you multiply 256, if you multiply 16 by 16, let's make sure this is right. 16 times 16 is 56. Okay? So what I'm going to do here is rewrite this problem as 16 to the power x plus 7 equals, instead of 256, I'm going to write 16 squared. And of course, we still have to write everything to the power x minus 4. So now what I'm going to do is I'm going to try to have the same base. I'm not going to, 16, I'm not going to use. This one, I'm not going to change it to 2. I'm going to keep it 16. Here, I change the 256 to 16 squared, right? Now, let's remember. You remember the power to power, something called power to power. If you have a power to a power, then you multiply AB. So in this case, we have a power to power. So let's multiply 2 times x minus 4. So here we get 16 to the power x plus 7 equals 16 to the power 2 times x and 2 times 4, which would be 2x minus 8. Okay? So all I did here, I used the power to power. This is b. So I have a power to power, I multiply, and that's why I multiplied the 2 and the x minus 4. But notice now I have a 16 as my base, I have a 16 as my base. Because we have the same bases, we must have the same exponents. So therefore, here we're going to have x plus 7 equals 2x minus 8. Okay? X plus 7 equals to x minus 8. Let's solve for x. Again, to solve for x, we're going to subtract x from both sides. This way we get rid of this x. And to move the 8, we add 8 to both sides. And that way, we get rid of this 8. So I'm going to end up with 15 equals x. And that's the final answer. I end up with 15 equals x. So again, in a problem like this, try to have the same base. Once you have the same base on the left and on the right, then you are forcing the exponents to be equal. Because to have a same base, you must have the same exponents. Otherwise, it does not happen. All right, let's look at the third problem now. Here's the third problem. I have a log equals a log. In this case, this is what I'm going to do. I'm going to use the same property I used before. For subtraction, I'm going to change it to division. So I'm going to write this problem as log of base 10. If there is no base, it's base 10, and we don't have to write it. So if there is no base, it is base 10. I'm going to write it as a ratio. X plus 7 over 2 equals log of 3x plus 2. Okay? So the first step I did, the subtraction, I changed it to division. And now I have a property, if you remember. This is the property that I have. If I have log of x equals log of y, then this is equivalent to x equals y. So using this property, I'm going to apply it here because I have a log equals log. That means x plus 7 over 2 equals 3x plus 2. Okay? So now I have to solve this simple linear equation. The best way to solve this simple linear equation is by multiplying both sides by 2 to simplify the fraction. This by 2, and all this I multiply by 2. So here the 2 and the 2 cancel. So I end up with x plus 7 equals 6x plus 4. Okay? I get 6x plus 4. Now, again, I'm going to do the same thing. Subtract x from both sides. And I want to move the 4, so I subtract 4 from both sides. And by doing this, I cancel the x. I get 3 equals 5x. Of course, to solve for x, I need to divide both sides by 5. And by doing this, I get x equals 3 over 5 as my final answer. All right? Hope that helped. Good luck.